central authority, you can do it as locally as you like, or indeed you can have a complete standalone network with your own issuing authority, in the same way that we do on many of our networks now with issuing private IP addresses and that kind of thing. But I mean, that ultimately provides a very strong solution to the authentication problem, as well as having the lightweight option. So in terms of, we've talked about the DNA to some extent. We've talked about the airdroppable base stations and the unlicensed spectrum telephony. And ultimately, if we're dropping in base stations, we'd actually have them tied in with a mesh and backhaul. So the protocols that we're using directly on the phones, whether it's through a mesh potato or a mobile phone, an OpenBTS GSM base station would use the same mesh and backhaul. So that if you're on your GSM phone and there was one of these base stations dropped in, again, the phone would actually ring you and say, welcome to whatever emergency phone network. And if it can't actually extract the number directly out of the phone, I think depending on the model of phone and the network, it may actually be possible to do that, which would obviate the need to query it directly. But if you had to, you could still get people to claim their own number on the GSM phone. And again, that would create a subscriber record, and it will all tie seamlessly into the network. So whether you're using a legacy GSM phone or whether you're using a Serval backphone or a mesh potato, we can actually form one very convenient to use network that doesn't require any special knowledge. And I think together, all of these four things create a system that will allow telecommunications anywhere, anytime, which is very much what we're aiming to do. Because in principle, you could be in a mine underground, and you could have people communicating in the mine, and you just might need to have, you might put a mesh potato or a phone wherever you have direction changes in the shaft, or if you have a central shaft for the lift, you might put units periodically down that at each level. But that would provide quite a compelling solution. Actually, in fact, for mines, then where you've got accommodation in a remote location, you can set up a nice convenient phone network for them as well. When there's many, many uses for it. So the project is very much standing on some tool shoulders. So we're using the Village Telco mesh potato software stack with the Batman mesh routing software. We're using Asterisk. We've actually got it ported into the mobile phones, which was an entertaining exercise. Because the linker on the Android phones and they're running Linux, but they don't use the standard Linux linker. So it was a bit of a hassle because Asterisk loads modules in, so we couldn't actually statically link the whole thing, or otherwise we wouldn't have had the modules. Or in fact, if you statically linked the binary and ran it, and then you load the modules, and the modules can't see the symbols in the statically linked binary because it's an A.out binary instead of an ELF binary, so that you can't query it. But we worked our way around that. The SIP client for Android never assumed that you would have a local PABX installed on the phone. So, that's right. The lack of foresight. So we had this frustrating few days when we were actually building all of this. We're trying to get it to talk, and SIP-Droid is saying, "Oh no, you can't make a call because you don't have a fast enough data connection." And I'm like, "Yeah, the loop back interface is perfectly fast." And then we dealt with that, and it was half working, but it wasn't offering any codecs. And when I eventually dug into the source code for SIP-Droid, each codec checks that the link speed is fast enough. So it was, in the end, it was about a dozen lines to fix it properly. But it was these fun little things that you don't expect to find. And SIP-Droid actually has a whole pile of problems, and we may actually move away from it anyway. It seems to have really quite bad latency problems, adding hundreds to thousands of milliseconds. Partly, I think, because the phones are bad at context switching, so you've got Asterisk and SIP-Droid context switching back and forth a little bit. Also on the mobile phones, every Android phone typically has a completely different Wi-Fi chipset. So controlling ad hoc mode and those sorts of things is a real nuisance. But fortunately, there's an Android Wi-Fi tether application that some people wrote that has probably, I think it's about 1,000-line script that says, if you're on a HTC Dream, then do this. If you're on a Nexus 1, do this. If you're on a Samsung Galaxy, you do this to control it all. So we've taken that, we've adapted it to start Batman and start DNA and run Asterisk and do all that control, which that saved us an enormous amount of effort. It meant that we had a shiny GUI for when we did some of our testing. So in terms of how DNA actually works, it's in fact alarmingly simple. If you're familiar with ARP for resolving IP addresses and Ethernet addresses, it's the same basic idea. So you send out a request, so who has, that's my mobile phone number, and a node on the mesh will respond and say, okay, that's available at the following SIP address. And then you just place the call ordinarily as you would with SIP.
Is this a broadcast in the mesh?
It more or less. So what we're doing at the moment, we actually tie into Batman, we connect to its socket to query out the complete list of nodes, and then we actually send out a packet to each node on the mesh. Because I don't trust true broadcast on a mesh. But of course, the first time you make the call is when you need to do that. If you've actually remembered that a particular subscriber ID has the number you want, you can actually go, okay, what IP address were they last at? And you can query that one directly. And if it answers, then you go, excellent, good. And you can then immediately place the call. Otherwise, you may then need to go out to the other nodes to query it. But I mean, the packets are very, very small. So we're talking a UDP packet of the payload of maybe 50 bytes. So even if you have to send it out to a few hundred nodes, this should be reasonably feasible. So yeah, we are ultimately still using the layer 3. I think there's some plans with the mesh potato to go to Batman Advanced in layer 2. So we'll rethink how we do things, but what we may actually do in that case is actually just do it purely on Ethernet and skip the UDP layer in between for simplicity. One of the things that I'm keen to do at the moment, we need root access on the phones to run the meshing. So I'm actually thinking of modifying Batman DNA and a bunch of other things and making one big hairy executable that avoids context switching and actually implements the mesh as a user land layer. So that, sorry?
You would not skip the context switching, you would get two context switches for each packet you forward.
Yes, that's right.
Not a good idea.
No, but at least that's kernel to process, which I think on the phones is much faster than process to process. So I think there's some strange things with the, because switching from Java processes to C processes, and I need to do some performance measuring to actually find out where the big delays are coming in, but there's some very strange latency happening within the phone from what we can tell. So I'm keen to explore different ways that we can deal with that. We're making it all available in GPL as well because we think that this should be helping all people. So, and there's some very good reason altruistically, and then also to enable the project to happen. So I work for Flinders University, is my kind of day job, and I've been doing this largely in my spare time. And our university has a ministry of commercialisation, if you will, which is...
You're under duck.
Sorry?
With your ducky.
Yes, that's right. So if it's open source, they can't stop us working with it. But also, I mean, it's also we have the Serval project incorporated is an incorporated body that is all IP that I can assign to it. I have, and our student who worked on it, he's assigned all his IP, and we have someone else from outside the university, and all of the IP that they've created is all officially vested in the incorporated body. So the university at most could claim a few percent for judicial interest in the project, but not a controlling interest, which is the key. And so I'm still working through that process with the university, and hopefully we'll get that settled. But one of the good things that I think that will help us on that front is that the project's already generated some good media for the university. So I have a habit of getting myself in the media from time to time in good ways. I've even been on our local current affairs show, without them chasing me with the camera down the corridor. So, and the university likes that kind of thing. So that's helpful. And if we get funding, then they'll be even happier again, and they'll stop getting worried. So this is kind of, a mock-up of what we can see happening down the track. So at the moment we have mesh potatoes, we have mobile phones happily talking to one another. We're planning to add the open BTS tied into the mesh as well, so that you can have conventional mobile phones. And then you might have satellite links to backhaul it if you're in a particularly remote location. Or you may have direct DSL lines, or all manner of other connections back to civilization. And it may in fact even be that you have a mobile phone using the 3G connection to actually get backhaul for a mesh. And I think it's actually one area where we might be able to get some traction with telcos as they continue to find that too many iPhones suck their bandwidth dry, for them to be able to push calls out onto a mesh for fringe coverage and around black spots where geography is challenging, that might actually take a little bit of the sting out of the the concept of people being able to make free phone calls, because I think the telcos will be apprehensive, shall we say, yes, at this concept. Because ultimately we can set up a phone network, anything, we can set one up here on this desk and around this room in about 15 minutes this morning. So our result, of course, is the mobile phones running our mesh software, and we'll pass them around. Planning not to talk for the whole hour and a half, and we'll have a bit of a play around with the network. So the world's simplest mobile phone network is this: 2 phones. They are a network. They can ring each other using conventional numbers, and they'll work. If you want to fly to the far side of the moon and have a chat in your spacesuit, you need absolutely no supporting infrastructure, and you simply can't get simpler than that. And of course, it's very difficult for a telco to actually kind of get in the way of that working, because you don't so much need as even an access point. So I used some very fancy graphing software this morning, as you can see, to talk about this issue of conventional mobile telephony and what we've done. So I'm not sure, it's a little bit dark here, but so with infrastructure, a conventional mobile phone network is, let's say, somewhere between pretty good and amazing in terms of the performance and quality service that it can provide. Whereas what we've created is, so we're probably about pretty good. You might not be able to get calls through depending on interference and range and a number of factors, but it can work in a good number of locations. So the problem, of course, comes that once the infrastructure disappears, your conventional phone network is, I actually think, slightly south of useless, because your phone will actually sit there and deplete its battery alarmingly fast. As we actually found when we did some testing in the outback, having the GSM radio on, blaring away at 4 watts, looking for its mummy somewhere out there to connect to, actually depleted the batteries faster than the mesh network radio did. Whereas the mesh network, without infrastructure, well, it's still more or less pretty good. It behaves exactly the same whether or not there is any supporting infrastructure. So when I talk to carriers, if they ever decide that they will talk to me, is I want to kind of point this out that in an urban first world setting where there's all of the money for them to get from phone accounts, that they have the advantage. People will always still have their conventional mobile phone service because they want to make sure that they can get a call through any time when they want to. But where our benefit is where that's not possible for any reason, we now actually have a compelling fallback. And for governments, it's actually interesting, we've been talking, actually the Attorney General's Department federally in Australia has actually approached me and said, we think this is very interesting for disaster preparedness, emergency services, all of these sorts of applications that have the potential to save lives because it provides a telecommunications capability that, for example, Osama bin Laden can't blow up. Or that you can go to a siege situation, or where you might think there might be a bomb or whatever, and you can go, okay, we'll turn off the local mobile phone network and the fixed line phone network to the fruitcake in the building, but the police force can still communicate in a very convenient way. So I think there's scope, if the telcos will listen, to sort of say that this is a good complementary technology, but I think we'll actually get traction with the government first over the benefit. So it's not just the Attorney General's Department that have approached us, a couple of state government departments, one of the police forces in Australia, and curiously one of the human services divisions. So they look after things like child protection services in Australia. So their concern is they go out to rural areas or remote areas to check up on the welfare of children. You can have quite volatile domestic situations, which is actually where most police and government workers get hurt. And they can go, okay, park the car has a satellite uplink on it that ties into the PSTN network. You go, oh, no mobile phone coverage, that's fine. You turn the thing on the roof and you go, oh look, we've got mesh coverage. And as long as we stay within a couple of 100 metres of the car, we can actually call for help and get a call through immediately, or we can get new information through on the network. So it's actually quite encouraging the input we're getting. And my second amazing graph, talking about the benefit trade-off. So now if we look at the cost to then think about the combined cost-benefit equation. So we have the scale here from $0 up to billions. And of course, rolling out a nice GSM network is somewhere north of the billion mark. And I've been rather rash and said, let's say about $10 to roll out a network that needs no infrastructure. Because you might want to put some stickers up somewhere saying that, we like the network here. So when you combine the two, the cost-benefit equation is, incredibly compelling, particularly for areas that aren't serviced by GSM networks at the moment. So, if we were to go to Australia is actually, particularly South Australia, almost uniquely has a very large number of very small towns. It used to be bigger when there was more farming further north, or when there was the river ports were used and these kinds of things. And they're now quite small communities that, like their lifestyle and refuse to kind of move to the city with everyone else. And that's kind of part of the Australian ethos, that they're entitled to do that. But you go, well, how on earth do you get telecommunications out to them? So at the moment, the monopoly carrier. So if you have a sheep station out in the middle of the outback, you go into town and go to your local Telstra shop and say, oh, I'd like a phone line on. And they go, grumble, and they say, well, please give us $800, because that's the mandated contribution you make. And then 3 weeks later they turn up with a huge truck and they offload a 2-metre satellite dish and solar panels and diesel generator and everything, and then run your copper line 20 metres into your house and go, there you are, sir. You now have a phone line. It's cost Telstra probably $50,000, even though there might only be 10 or 15 kilometres from a town that actually has a trunk line connected. So again, you could actually set up a peninsula of connection out, which again would actually be a cost-effective solution. So my dream is that one day we'll see phone packaging like this. Probably not on the same piece of paper, but here we have Nokia, our open source handset provider. So we've got connecting, not just connecting people, but it's connecting all people anywhere, anytime. And you can get it on your prepaid plan for say €49. You can have like a nice cheap phone. So we have a lovely handset here. And so we've got the a nice little picture of the world, and it says it's quad band and backphone 2400 for global use. So using Wi-Fi 2400 megahertz. Free calls with free local calls with Serval backphones. So I mean, these are compelling marketing advantages for any handset vendor. And then works when towers are unavailable. For example, during emergencies. That's going to make all the mums and dads happy to go, oh, we can get little Johnny a phone that will work even if we're out of coverage.
How long does the bad phone keeps up with one battery? Because you constantly need wireless communication. In my experience, Android phones are gone within hours if you constantly use the wireless LAN. So
in actual fact, an Android phone, whether you use the wireless LAN or not, is gone in hours.
But in normal standby, when I can receive GSM, it takes days until to go out.
Okay.
So
the dreams are actually quite atrocious for any measure of battery consumption. So on standby on GSM, I think 12 to 24 hours is all that you typically
2 or 3 days, including UMTS. On this phone, I have a G1 too, and I recharge it, I think 2, maybe 3 times a week.
Okay, you're doing better than I'm doing back home in Australia. Sorry, go on.
For a typical emergency situation, you got a spare battery pack for it. So the mono cells or something like this, they last a couple of years. You take a soldering gun and you put together 5 volts or so and put that into the...
Don't think they will last as long as the lithium-ion battery.
Yes. Yeah. Because the power consumption is really only 500